Hello, welcome to your 7-3 podcast on completing the square. Now, the past couple days we have talked about different forms of a quadratic equation. We talked about general form, we talked about vertex form, and we talked about factored form. Today we're going to focus on general form and vertex form. Okay? And in particular, we're going to talk about converting from general form to vertex form. Well, there's a couple things we need to talk about first. The first thing is a perfect square trinomial. And a perfect square trinomial is exactly what the name says. It is a trinomial, which means it's a polynomial with three terms. And it's also the perfect square, which means it comes from the square of something, which in our case is going to be a binomial. Okay? So if you take a look at these four that I have up here, okay, picture on the way. Um, this is stuff you did back in algebra. So if I want to square x plus 5, okay, that's the same as x plus 5 times x plus 5. And then you would distribute. You get x squared plus 5x plus 5x plus 25. So all together, combining like terms, x squared plus 10x plus 25. Okay? And then similar thing, even if you have like a number in front of your first term, or if the sign's negative, you could do it the exact same way. 3a minus b times 3a minus b equals 9a squared minus 3ab minus 3ab plus b squared. Combine some like terms. You get 9a squared minus 6ab plus b squared. Okay? Now, these guys on the end are called perfect square trinomials. Okay? Well, what I want to do real quick is just generalize that process. And we've talked about this a little bit. Like, what could we come up with a shortcut for squaring a binomial? Okay? So, like, for instance, I put these two down on the bottom. Okay? One thing you should notice is that the first term of the trinomial is the same as the first term of the binomial squared. The last term of the trinomial is the same as the last term of the binomial squared. And then the middle term, notice here it was 10x. And 10 is the same as 5 times x times 2. And we're doubling because we got those two middle terms of 5x. So altogether you have 10x in the middle. Or sorry, excuse me, 2ax in the middle. Similarly, if it's subtraction, it would work pretty much the same way. A squared, your last term's still going to be a squared, because when you square a negative, okay, you still get a positive value. But your middle term is minus 2ax. Okay? Now, again, these are all perfect square trinomials. All right? Now, my question to you guys is where we're going to go with this completing the square process is I'm going to give you the first two terms of a trinomial. Okay? And my question to you guys is what does this third term have to be if it's going to be a perfect square trinomial? Okay, so for instance, in this case, x squared plus 6x. Okay, what would that last term have to be? Well, compare what we have there to the previous screen right there. Okay, I know that this is x squared, that I have that in my other problem. This is 6x, so what would I have to add on to the end? Okay, well, if you think about it, your a value, if you kind of compare the two, would have to be 3, and then whatever 3 squared is what I need to add on. So what I'm going to do is add on 9. Okay, and what happens is, if you take that trinomial now and you factor it, so just like we started reviewing yesterday, okay, you'd have x and x out in front, you'd have two plus signs, okay, what numbers could go in back? Well, 1 and 9 or 3 and 3. The only way that works to get 6 in the middle is 3 and 3. Notice it's your factored form is a binomial squared. So what I'm going to have here is x plus 3 quantity squared. This expression is the same as that expression. Okay, so that little process of finding that missing constant term and then factoring it is called completing the square. Okay, so in general, let's kind of summarize a little bit. Okay, given this polynomial x squared plus bx, okay, what are you going to add on? Well, notice what we did. We took that middle term divided by 2, and then we squared it, and that's what we added on. Okay, so what I can do, I can take b over 2 and square it. That's what I add on. Okay, Once I add that on, it's going to be a perfect square trinomial, which can be rewritten as a binomial squared. And notice how this 3 is related to the 6 and the 9. Okay, the term that's going to go right here is whatever that b over 2 was before you squared it. Okay, so that's the process of just completing the square, making something a perfect square trinomial, and then kind of factoring it out, writing it as a binomial square. Okay, all right, now seems a little complicated, but now we're going to put it together with a couple other things. Okay, these are the steps we're going to follow. Okay, so if I'm gonna do the whole process. Let's start with general. Let's convert it to vertex. Okay, first thing you're gonna do, factor out the leading coefficient. Okay, so if you have a leading coefficient, we're gonna get that out of the way. Okay, second thing is we're going to do that completing the square process. Okay, and then lastly, we're gonna finish by rearranging and putting into vertex form. Okay, so here's two examples. Okay, now notice the one on the left doesn't have a leading coefficient, so we're not even going to worry about that. Okay, so what I'm going to do is I'm actually going to take these first two terms and group them together. Leave a little space. So just like on the previous two slides now, okay, these are the two terms that I'm going to use to complete the square. All right? So now what I need to do, I need to figure out what gets added on inside of here so that becomes a perfect square trinomial. Okay, so again, just like on the previous slide, I'm going to take that middle term, negative 18, divide it by 2, and I'm going to square it. Okay, so when I do that, I get negative 9 squared, which is 81. Now, a lot of you right now should be going, hey, Mr. Schmidt, what's the deal? You just randomly added 81 to the inside of an equation. You can't do that. My algebra teacher told me I couldn't. Okay, so to compensate for that, okay, what we do is I added on 81 to my right-hand side of my expression. And again, that's not technically algebraically legal unless I compensate for it. Okay, so what I'm going to do, I added on 81. I'm also going to subtract 81 from the right-hand side. So notice, if I add 81 and then I subtract 81, that's the same as adding on 0. So if I'm adding on 0, I'm not technically changing the value of the right-hand side. So that is algebraically legal. Okay, so now what I got is this. X squared minus 18x plus 81. And then this is going to be plus 19. Okay, now I can factor that little set of parentheses. Don't just leave the 19 where it is. Okay, and I'm just going to factor that set of parentheses there. And what's nice is it factors into a binomial squared. Okay, so you could go ahead and factor it by hand. Go, x and x have to be your first two terms. Your two signs have to be subtraction. Your numbers in the back both have to be 9. So it factors into x minus 9 quantity squared. And what's nice about this, okay, is now I know exactly where the vertex is. The vertex of this parabola is at 9, 19. Okay? And that's the whole point of completing the square. I can take a general form, I can convert it into a vertex form, okay, and then I can figure out where the vertex is. Okay? Now we got to do one more. And this one is going to be a little bit different. I'll just copy this one down below. Starting off with y equals. The big difference between this one is it's got a 3 in front of the x squared. So I'm going to have to take care of that. But if you think about the steps I gave you before, the first step was to kind of factor that out. So we're going to get it out of the way. But again, what I'm going to do is I'm going to group together these first two terms. Now I'm going to use factoring here, but I'm only going to use factoring on that set of parentheses. So what I'm going to do, y equals 3 times the quantity, x squared plus, and now again I'm dividing both of these by 3, so that's going to turn into 8x. Okay, and actually I'll leave a little space here just to kind of save some room, and then I'll have the plus 5 on the outside of that. Okay, so now this right here is the expression I'm going to do the completing the square on. Okay, so just like before, take that b term, divide it by 2, and square it. That's what gets added on. So in our case, it's going to be 8 divided by 2 and squared. So that's 4 squared is 16. So I'm going to add on 16. Okay, so again, I can't just randomly add 16 onto one side. I'm also going to have to subtract 16. Ooh, wait, I didn't technically add on 16. I technically added on 3 times 16. So what did I add on total? Because notice the 16 was on the inside of the parentheses, and those parentheses are getting multiplied by 3. So technically, I'm adding on 48. So what I'm going to have to do to compensate for that is I'm going to have to subtract off 48. Okay, so make sure if you have that leading coefficient out in front, okay, you are technically adding on 3 times that in this case. So I have to subtract that off. But now, I can combine these two constant terms on the outside, which will be minus 43. And then I can turn that set of parentheses into a binomial squared. I can factor it out. So if you want to factor it by hand, go ahead. If you remember our little rule, it'll be x plus whatever this term was on the inside. So your b divided by 2, in our case it's 4 here. I'm going to have x plus 4 quantity squared. Okay, so now I know my vertex is at negative 4 comma negative 43. Like that.
Okay, the last thing that I'm going to mention today are a couple little application problems that deal with quadratics, in particularly things that have a projectile motion. So this is anything that can be thrown in the air. You'll explore this a lot when you take a physics class. Any sort of projectile, anything that's launched. You're talking about a football, you're talking about a soccer ball, all that kind of stuff. Um, the ball's height versus time, okay, has a formula that is a quadratic equation. Okay, so in this case, the y value is negative 1/2 times the value of gravity times x squared. In our case, x is time, in particularly in seconds. Okay, and then plus your initial height on the end. Okay, now the possible values for gravity are dependent on what kind of units we have for our other values for velocity and height. If things are measured in feet, I'm going to use 32 feet per second squared. If we're going to use meters, I'm going to use 9.8 meters per second squared. Okay, so for instance, an example, Nora hits a softball up at a speed of 120 feet per second. Her bat contacts the ball at an initial height of 3 feet above the ground. How high does the ball actually travel? When does the ball reach its maximum height? Okay, so all I'm going to do is take that formula, negative 1/2 g, in our, they use negative 1/2 g, they used x squared plus v sub 0 times x plus h sub 0. Plug in my values. Okay, so I'm going to have y equals negative 1/2. Now I'm using feet here, so I'm going to use the value of 32 for gravity. Well, when I plug in times 32, well, negative 1/2 times 32 is negative 16. So I'll put that in. Plus my initial velocity, which is 120. Plus my initial height of 3. Okay, and now from here, if I want to find the maximum height, what I can do is I can complete the square. Okay, so what I'm going to do, group these first two terms together. Negative 16 times x squared plus 7.5x plus, and then leave your plus 3 on the end. Okay, now what in the world do you add on inside of there? Okay, so what I'm going to do, same thing as before, take your 7.5 divided by 2 and square it. That ends up being 14.0625. Okay, and now I can factor the thing. the set of parentheses anyway. Oh, sorry, skipped one step. If I add on this 14.0625 on the inside of the parentheses, technically that's 14.0625 times negative 16, okay? Which if you multiply that out is negative 225. So to compensate for that, I have to add 225, okay? And then I can rewrite it. If you factor the set of parentheses, now again, don't try to like factor it by hand. Use the pattern we learned before. It'll be x plus, okay, and again, whatever that b divided by 2 was. Okay, b divided by 2 is 3.75. Okay, and then on the end I have plus 228. Okay, so what I have here is I have that same polynomial just in vertex form. Okay, which tells me, oh, I made a quick mistake. Let's fix it. When I factor out negative 16, this will be negative 7.5, which is the only difference here is this makes this negative 7.5 inside of there and negative or minus 3.75 there. Okay, so now I know where my vertex is. Okay, and my vertex is going to be at 3.75, comma 228. So the maximum height is 228 feet and 3.75 seconds. Like that. Okay, so basically one of the big things you can, or one of the main ways you can use a vertex, you can use this whole completing the square process is to find the vertex or the maximum of a parabola, or minimum for that matter. All right, we'll see you tomorrow.